Hello, this is Algebra 2, topic 2-4 on how to use logs to solve exponential equations. So the first thing is just the basic setup. We have 3 to the x equals 30. Well, if you remember, log of base b to the answer equals the exponent. So our base is 3. So we're looking at log base 3 of 30, because that's our answer, equals our exponent of x. Now to solve this, we need to do log of 30 over the log of 3. We use our calculator. And we get that it is 3.096. Moving on to example number 2. Well, in order to solve this, we have to have it set up much like the one in example number 1. We need some number to the exponent equals something so that we can work with it. So what I'm going to do is I'm going to go ahead and just add 4 to both sides, and I get that 10 to the x power equals 38, which means that log base 10 of 38 equals x. Well, this is just the basic log. So I can just type in the log of 38, because our basic log is the base 10 log. So we have log of 38, and that equals 1.580. Because this 1.5797, that 7 rounds that 9 to a 10, which turns that 7 into an 8. Let's go ahead and have a look at example number 3. So example number 3, 5 to the x plus 14 equals 21. Well, I need to get the exponent off to one side, so I'm going to subtract 14. We get that 5x equals 7. So log base 5 of 7 equals not 5, but x. So we're going to type in log of 7 over the log of 5 into our calculator. We have the log of 7 divided by the log of 5. When we enter, we get 1.209. Over here, 1.580. That's our first 3 examples. Let's go ahead and look at the next page. Well, again, we want to go ahead and just get our exponent by itself as much as we can. So I'm going to subtract 4 from both sides, and I get 3 times 1/2 to the x equals 15. I then divide by 3, and I get that 0.5 to the x equals 5, because 1/2 is just another way of writing 0.5. And so now I have the log 0.5, base 0.5 of 5 equals x. So that would be the log of 5 over the log of 0.5. And that gives us a negative 2.322. Moving on to our next example. Here it gets a little more complicated because we have something more complicated as the exponent. So this is the log of base 2 of 3.6 equals 4x. Actually, we're going to go ahead and change this up a little bit. When your exponent is more complicated, you can't solve it just by doing logarithms on one side. We actually need to do logarithms on both sides. So I'm going to take the log of both sides. The log of 2 to the 4x equals the log of 3.6. Move this around. 4x times the log of 2 equals the log of 3.6. If we divide both sides by the log of 2, well, these will cancel, leaving 4x equal to log of 3.6 divided by the log of 2 gives us 1.848. And then we divide that by 4. And I'm going to go ahead and just use this so I get a more exact answer. Divide by 4. And I get that x equals 0.462. Let's go ahead and take a look at number 6. It's the same way. I'm going to go ahead and take the log of both sides. So this becomes x plus 4 times the log of 19 equals the log of 3. So divide both sides by the log of 19. And when we do the log of 3 divided by the log of 19, we get 0.373. And this is x plus 4 equals this, so we just subtract 4 from both sides. Again, just use the same number, subtract 4, and I get negative 3.627. And so that's our answer, negative 3.627. So just going over this again, if you were given something where the exponent is complex, you have to take the log of both sides. If you're not giving something with a complex exponent, you can just use the rules of exponents to solve it, which I've got that actually written on this copy right here. Good luck on your assignment and have a good day.